Okay, folks, we're going to continue with part 3 of this video. There may be a fourth part depending on how long this is. It's kind of a long lesson. It's a very important and thorough lesson for this class. But last time we talked about the slope of the line tangent of f of x, and we said that that's what's called the derivative of x. Now, the derivative in terms of limits is going to be f of x plus delta x minus f of x all over delta x. So we kind of talked about this last time, but I want to make sure that I emphasize a few things. First of all, the definition of a vertical tangent line. When the derivative or the limit of delta x as delta x approaches 0 of f of x plus delta x minus f of x all over delta x is equal to either infinity or negative infinity, then that means you have a vertical tangent line at that particular point. But the derivative itself is as follows, and I'm going to highlight that in a different color, f prime of x. Now, you can write the derivative in multiple different ways. F prime of x, dy dx, y prime, and then there's the other two methods. Those are the three that I highlighted are probably the most common methods you'll see, but they all mean the same thing, derivative. And basically, derivative is basically the slope of a particular curve or line at an exact point. So that's a difference between calculus and also between algebra. You've learned to determine slope between 2 points. Now you're going to do it at exactly 1 point, instantaneous slope. But we're going to talk about that more, and that is what's called differentiation. Now, with the limit process, you're going to have to be able to use the limit process in your group activity. I've already posted the information, so you and your partner are going to have to come together virtually, either through Zoom, Google Meets, or whatever format you like, and present the one problem that you've been given. So you present that one problem, and I will post it on Canvas for everyone to see, so that way you can all learn from each other, and I will post them all there for you. All right. Now, we're going to use the limit process to help us determine the derivative of h of x. So here's what you need to know. H of x, as you know, is x cubed plus 4x. Excuse me, minus 4x, and I will fix that. I will fix that for you. H prime, H of x plus delta x. I am not writing well today, folks. I apologize for that. You're probably on the other end laughing. Trust me, if I was in your shoes, I'd be doing the same thing. All right, so it's going to be x plus delta x cubed minus 4 times x plus delta x. All right. Now, I gave you the information on how to do x to the third binomials like that. So I'm just going to write it down, and you can look it up on your information at your time. All right. So basically, h prime of x equals the limit of delta x approaches 0. Delta x approaches 0. This is like the second bout of technical difficulties I've had. All right, here we go. Which equals x to the third plus 3x squared delta x plus 3x delta x squared plus delta x cubed, that's just this part, minus 4x minus 4 delta x. All right. Then minus h of x. Minus this, so minus x to the third. Minus minus makes it plus 4x. And that's all over, in this case, it's going to be delta x. All right. So it looks like a lot, but basically it is, and I'm going to highlight these parts for you. It is right here, and I'll highlight this, and this right here. You can look at that and study it on your own. Okay. Then what I got to do is I got to cancel out the like terms. I got an x to the third, that cancels out. I got it 4x, they cancel out. So here's what I'm left with, equals 3x squared delta x plus 3x delta x squared plus delta x cubed minus 4 delta x all over delta x. All right, now what you want to do is you want to simplify and you want to cancel out all the like terms. Well, each of these terms has at least one delta x. So when we do that, we're left with 3x squared plus 3x delta x plus delta x to the second minus 4. All right. Now, if we take the limit of this, take limit as delta x approaches 0 of what's left, 3x squared. And I'm going to move out of the way in just a moment so you can see it. I apologize, but I'm trying to get this written for you. All right. We're going to take the limit as delta x approaches 0 of that. All right. When we do that, here's what we're left with. This cancels out, 0. This cancels out. And I'm left with 3x squared minus 4. So that means that h prime of x, h prime of x equals 3x squared minus 4. Now that is using the limit process. In the next section, I'm going to show you a different method. I think you might like the different method a little bit better, but you have to understand the limit process before you can do the other process. All right. Now you can review that or email me if you have any questions on it. Okay. Now, this one we have an absolute value. Now I want to draw the graph of this before we solve this because I want you to be able to see how that works. All right, so if you draw the graph of this, here's what's going to happen. The vertex is going to be at the point 3, 1. You learn that in algebra 2 and pre-calculus. And then it's going to go like this. So here's what's going to happen. It changes from the left and the right. You have to split it up into two parts. You got to first do the limit as, excuse me, I'm going to make sure I write this, as x approaches 3 from the negative side of, which in this case will be, and I'm going to go ahead and I'm going to write this down for you what it will look like. It's going to look like this. It's going to look like absolute value, x minus 3 plus 1 minus. And then we plug in our x. Since we know what x is, we know x is 3. I'm going to plug in my c value is. So it's going to be the f prime of x, where x equals, in this case, 3 from the negative side. So f prime of c, I plug it in. I've got minus the absolute value of, in this case, it's going to be 3 minus 3, put a parenthesis around it, plus 1, all over x minus 3. Okay. Now, here's what happens. All right. These 3's will cancel, and these 1's will cancel. So we're going to be left with x minus 3 over x minus 3. Now, you got to remember this. The slope from the negative side is going down, so it's going to be negative. So this is going to actually be negative x minus 3 over x minus 3, which means the slope or the limit is negative 1. And the reason why that's negative is because if you look at 3 from the left side, it's going down. Now, if I switch this up and I say the limit as x approaches 3 from the positive side, I'm going to do the exact same thing that I did here. So it's going to be x minus 3. Sorry, I'm thinking faster than I can write. I do that somewhat. I can do that sometimes often. So minus, in this case, 3 minus 3 plus 1 all over x minus 3. Now, once again, the 3's cancel and so do the 1's. So I'm left with x minus 3 over x minus 3. Now remember what happens is because it's coming, the slope is positive, then that means that the absolute value is going to be positive. So therefore, it's going to be x minus 3 over x minus 3, which equals 1. All right. Now, what do we do when we have coming from the left and coming from the right? The limit does not exist. Basically, it is not differentiable because such limit not differentiable. It's not differentiable. Does not have a tangent at. Does not have a tangent at x equals 3. Since it does not have a limit, it does not have a tangent at x equals 3. Okay. Okay, I've got one more problem with you, but because I'm going to run out of time before this ends, I'm going to go ahead and do part 4. So I will be back on in just a couple minutes.